Words for Evil is a 2014 typing game with RPG elements made by Dylan Loney and is fairly minimalist. A couple of years ago I demonstrated playing this using voicefinger to spell each word, because with the tools I had available at the time, this was the quickest way I had to accurately send words. Since learning coding in Vocola 3, there are now ways of playing it more efficiently and without using voicefinger. The primary problem encountered when using Dragon Naturally Speaking or Windows Speech Recognition was that they would send all letters of recognized words, or spelt words, in one go, and the program can't handle them all at once, receiving them in a random order. Sending the letters of recognized words more slowly, and yet more quickly than possible with voicefinger, was the problem I set out to solve. All the Vocola code will be in the description of the YouTube video, except for the angle brackets. I have to put these around variables I'm defining, but YouTube doesn't want the angle brackets in its descriptions anymore. So, somewhat arbitrarily, in the description I'll have less than signs replaced with percent signs, and greater than signs replaced with asterisks. When you copy the code into your own .vcl file, use Microsoft Word, WordPad, or EditPad Lite to replace all of these back. First off, it makes sense to have some commands for pressing the cursor keys multiple times for easily navigating menu options. I've used the repeat function for these, as the default way of sending multiple keys sends them far too quickly for the game to distinguish them. Down 5, right 3, up 2, left 2, down 10. Similarly, it's worth putting in commands for correcting mistakes by sending backspace once or multiple times, confirming choices, shuffling letters, finishing traps, and pausing. The game wouldn't acknowledge the normal way of sending shift. However, using the hold and release function alongside a short wait made it work. Here I defined a variable called letter, which can be any letter from the alphabet. I then have these 7 commands, each of which has the optional prefix spell. When I say a sequence of letters, between 1 and 7 letters long, with or without the prefix, it moves to the appropriate command, and then it will send each of the letters I said 15 milliseconds apart, until it's sent all of them. 15 milliseconds is enough for the game to not get the letters the wrong way round. It's possible I could have used a lower number, but this is fast enough. WIG space LADS space spell TRUNK space. Note that this first command should send any letter of the alphabet if you say it, though there are some letters it confuses, like M and N and I and Y. So I added individual commands for the entire phonetic alphabet, to aid whenever I needed to send just one extra letter. Also, it would often confuse home with O and delta with tilde, so I've added these to correct that. Note also that programs like VoiceAttack and VoiceBot could not handle this range of possible inputs, which is 26 to the power of 7, and twice that accounting for spell being in front. Something about the way that Vocola 3 uses the Windows Speech Recognition system means that the computer doesn't get overwhelmed even when you exponentially increase the range of possible inputs. Despite all this, you may find it doesn't quite work. Spell GOON, as I often find that any extra noise between any of my letters leads to extra vowels being added. And while in the grid maybe that won't be a problem with the word root you're trying to find, sometimes it is, and you end up having to delete some and then try and add them again and get caught in a bit of a loop. So I needed a backup option. I made another variable called alt, which is composed of the entire phonetic alphabet. I then replicated the same 7 commands as before, switching alt for letter, although also using this function left to take in the variable term instead of just using the variable term on its own. The function left with a 1 as its second input will return the first letter of this variable term. And as every word in the phonetic alphabet starts with the letter that it's supposed to refer to, these commands will return the first letter of every phonetic word spoken in a sequence. Again 15 milliseconds apart. Again this has the prefix spell, but given that as soon as you've said two of these, it knows absolutely that you're using the variable alt, it's not that necessary. Note that while this is the standard phonetic alphabet, if you're writing code just for yourself, and there are some phonetic letters in here that you tend to get wrong, then you can just change them, or add in extra ones. For example, I can add in brimstone as another option for the letter B, and while I've been pronouncing PA as papa in Dragon for several years, Windows Speech Recognition prefers I say papa. Here I can put paper and pepper alongside papa, and Windows Speech Recognition will default to one of these when I say papa, instead of making the wrong guess. Also, if you happen to be trained on versions of the phonetic alphabet from the early 20th century, you can just use those instead, or even the version that Western Union uses. The only restrictions for this setup are that you need at least one word for each letter of the alphabet, that the words must start with the intended letter, and that the words need distinct pronunciations. So it would be a very bad idea to include ku, do, gu, su, to, undo, and oo, as it would get all of them confused. Spell Sierra Oscar Alpha Kilo. Space. Tango Romeo Alpha Charlie Echo Romeo. Space. While it will take you longer to speak these sequences of letters, they'll be received more accurately, and so you'll have less correction to do. Now I mentioned the function left. This is from the string library, and at the top of this VCL file I've got $ using Library.String, meaning that all commands from the string library are going to be available to me as I write this code. If I didn't have this, then the program would throw up an error asking me what does left mean. The function left takes in a word and a number, and then outputs the first this number letters of this word. So left fish 3 is FIS. Left habitat 2 is HA. The only restriction is this number has to be non-negative and probably not 0, and at most the length of the word. So if you give fish 5, it will throw up an error. Similarly, there is the function write, which takes a word and a number and returns the last that number letters of the word. So write of fish 2 is sh, and write of habitat 6 is habitat. Again, the number needs to be between 1 and the length of the word. If for some reason you didn't want to use the using Library.String bit at the top, or perhaps you were only using left and right once or twice in your code, you can use string.left and string.right as the shorthand, meaning that the string library commands would not be available elsewhere in your code. Finally, after a lot of research and testing, I used functions in Vocola for setting variables, getting variables, and calling functions to make a single recursive function that will send each letter one at a time for any word that is prefixed by send, center, sent word, or dash. Given the limitations of Vocola 3's code, this took me quite a while to put together such that it actually worked, so I'm going to go through it, but we'll unpick it slowly. Firstly, note that there are two variable terms in this, the first one being any of these. I just wanted to use send as my basic command, but sometimes it would recognize center or sent, and if someone wanted to say word, or perhaps dash as it's slightly faster than send as a word, then I included those. But the variable term we're interested in is the second one, referred to by $2. So firstly I take the second variable term and apply the function join words with this as its second input. This combination of inputs will remove any spaces from my second variable term, which is useful if Windows Speech Recognition misheard me but still got roughly the right letters in the right order. And removing space from the string that it's processing means that as it sends letters one by one, it doesn't accidentally send the word early. Then from the variable library, I use the function set. And so with variable.set, I set g1 equal to this outputted string, which has no spaces in it. Now because g1 was a variable I set, it's treated a little differently. I can't just refer to it. I have to use the get function from the variable library. So variable.get of g1 returns the string that is g1. Then I find out its length, and so I'm going to run the letter outputting code that number of times. The code that is repeated first gets the variable g1, and then uses the function left to send the first letter of it, then waits a short moment, and then uses here command. Here command allows you to run another Vocola 3 function or command as if you had said it, and here it runs a command I called myOtherFunction. From how I've set this up, you can already tell that what it will do is reduce the length of g1 by 1 by chopping off the first letter, and so we just have to unpick myOtherFunction to verify this. This is a single expression that does a ton of things in one go. First it gets the variable g1, finds out its length, subtracts 1 from it, and uses the function eval to evaluate that subtraction as an integer. It seems silly that I have to use eval, but Vocola is not very keen on arithmetic. So this whole expression is 1 less than the current length of g1, and this is the second input of the function write. I've used the function write to take in g1 via variable.get and this reduced length, and as a result, this whole expression is the variable g1 minus its first letter. Finally, this is used as an input for variable.set. Variable.set takes g1 and sets it equal to this whole other thing we created, which is missing its first letter. So it sets g1 equal to g1 minus its first letter. Then goes back in here, returns the first letter of that, waits a moment and repeats. Meanwhile, the number of times we repeated up here was calculated at the start, and so that doesn't change even while we shrink g1 to be fewer and fewer letters. And so overall, this sends every single letter with a short wait in between them. This wait might not be necessary because the computer has to crunch quite a bit with all this self-referencing in order to output each letter one at a time, so wait 0 might actually work. Now because this removes any spaces before it does any of the processing, it means I can say multiple words which have the sequences of letters I want in the right order after the word send, or sometimes I'll say a slightly longer version of a word, knowing that that one's more likely to be recognized. For example, I may say cases instead of case. Whenever this happens and I need to remove the last couple letters before sending, I have this function taking space and then a number, which will press backspace that number of times before sending space. It sounds a little counterintuitive that space means to just send space, and then space 1 means backspace then space. But this felt like the fastest way to send that, without coming up with a different expression for sending my words. Send posed. Backspace 3. Send opposed. Delta. Space. Send poacher. Space 1. Send swoons. Space. Send swigging away. Space. Send s'mores. Backspace. Send forest. Space. I did try including this single expression here in the loop, but it just didn't work. And all of this assumes that your words are generally heard correctly and the commands go through cleanly, which is not always the case, but it works often enough to be significantly faster than spelling letter by letter in VoiceFinger, even if you only use the sequential phonetic alphabet above.